Morning, everyone. Welcome to this morning's webinar, where we will be presenting the topic, Business Opportunities in the Circular Economy. Welcome, every one of you, IES members and visitors from overseas, and also fellow engineers to this webinar. We are very delighted to have our friends from A-Star, SimTech, as well as Temasek Foundation to be here with us to share this webinar with all of you. And we hope that through this webinar, you'll learn a lot more about the circular economy and also understand where the opportunities are and where you can participate to bring about better sustainability, better solutions in this circular economy. Okay, so I'm Andy. I'm the General Manager for IES INCA and will be a host for today's event. Okay, today's program, we'll have a short introduction to IES INCA for those who are new and here with us for the first time. And we'll have a short introduction to Temasek Foundation by Shruti. We'll have an introduction to A-Star SimTech by Joyce, and we'll be getting into the A-Star's research and knowledge about circular economy and the market opportunities, where Dr. Xue Chen will be sharing, and incorporating that will be a brief on this Smart Bin call for collaboration, where Christopher will share with you what it entails and where they are at. And we'll end off with a Q&A with the panel. You can ask any of us any questions relating to our presentation. And lastly, we will be hanging around and you can chat more if you want to, if you have specific questions you want to speak to us at the end of the event. Okay, so for those who are new to IES INCA, let me just share a bit about where we come from. IES INCA actually originates from the IES, which is the Institution of Engineers Singapore, which is an organization that has been around since 1966. And our mission is to advance and promote science and the profession of engineering for the well-being of mankind. The vision for IES is really to be the heart and voice of engineers, and as the national body of engineers to drive the progress and the professional development of engineers. Okay. This is our current IES Council. Dr. Richard Kwok is our current president, and IES Council forms from different engineers from different disciplines, also from government sector, private sector, and also academia. Okay, so we come together to support the growth of engineering. And we also have different technical committees that drive progress in the different sectors of engineering, which covers from infrastructure to newer ones like energy and future manufacturing, even biomedical. Okay, now we move on to IES INCA. IES INCA is an extension of IES, where we are doing the role of incubation, acceleration, and also supporting technopreneurs. So we connect our technopreneurs, our mentors and investors so that they can build successful ventures. Okay. And our mission is to support our engineers who are doing this tech commercialization in engineering translation and accelerating these products to market. And also a vision that we see is a vibrant engineering venture and entrepreneur community that really transform life through innovation and technology. Okay. Our USP as an incubator is that we are linked to the largest engineering network of body of engineers in IES, and we support and incentivize engineering talent towards creating of these products. And we are aimed to be the hub for all engineering related new ventures, connecting the IHLs, the research institutes, and also industry. So this is our current board of directors for IES INCA. We have Engineer Chong, who is our chairman, and Engineer Edwin is our current advisor, and various engineers as well as non-engineers who are supporting our activities. Some of the activities in the last 2 years plus that we had some networking events, we had lots of webinars to cover different topics so that we can bring engineers more awareness about the emerging trends and opportunities. Okay, so as IES INCA, our role is really to connect IES members, engineers, corporates, SME spin-offs, IHL spin-offs through engineering translation, mentoring, and business support to reach out to our investors, our business network, and also customer markets. We're also very happy to support new innovation opportunities where we bring corporate problem statements, industry problem statements, and also innovation opportunities to our IES members for more awareness so that they can jump into some of these new business opportunities and grow their technology and build the solutions. Yeah. So like today, this is a very great opportunity where we bring circular economy topics to the audience. Okay. Yeah. So IES Inca's role is to help companies in the scale-up stage. So we provide this business structuring, planning, source fundraising, and also mentor and IES network so that the teams can exit incubation with an executable business plan, necessary funding, and grow into the global market. Yeah. So these are our focus areas as IES Inca. We are looking at infrastructure technology, building related materials, processes, and facilities management, IoT for smart cities, robotics automation, and also clean tech sustainability. Yeah. So those who like to incubate with us, they need to have completed the customer discovery and validation journey, build MVP but need to scale, market size minimum of revenue of minimum 1 million above, and the key team member is an IES member. All the engineers here who are not IES members, you are welcome to join us as long as you have engineering related training and degree or experience. Some of our partners we are closely working with. The newest ones that we added is E27, it's a media partner, and also BOP Hub, which looks after emerging markets. And we also built up an IES investor network that has 12.2 million to invest into new technology companies. Okay. So we also want to reach out to SMEs in this within the technology space. We want to help them transform as well. So we created this program to do a business review with our panel of consultants and also to journey with them in the innovation new ventures. So SMEs who want to sign up for this review, do follow the link below. And we also run courses for IES members and engineers to scale up on their business areas as well. So welcome all to join us whenever we have these courses. Okay, so that's a brief introduction to IES Inca, and we're excited to have our next speaker to share with us on the Temasek Foundation activities. Okay, so a brief intro to our speaker. Yeah. So Shruti is the Senior Manager for Programs and Partnerships, and she's part of the Livability team at Temasek Foundation. I will hand over to her where she can share more about her activities. Over to you, Shruti.
Hi, everyone. Good morning, everyone. I hope you can hear me well. I'd like to thank Andy and Engineer and IES Inca for providing us with the opportunity to share more about our work at this seminar. My name is Shruti. I'm part of the Livability, establishing innovations and solutions to our sustainability and livability issues. I'll start off by providing a brief introduction on Temasek Foundation and the team. Briefly, Temasek Foundation has three main pillars. One is on fostering regional and international exchange, and this is undertaken by our international team. Second is in strengthening social resilience and uplifting lives, and this is undertaken by our team at Temasek Foundation Cares. And the next pillar is on advancing science and nature, and this is undertaken by Temasek Foundation Livability. Our mission is to support innovations to bring about products and services to improve the livability and sustainability of our cities. And my presentation today will be focused on Livability's core work and interest areas. Our areas of interest in the livability and sustainability space include the following on this slide. Some of the areas that we cover include food security, energy, decarbonization, and the circular economy. We are also focused on public health innovations, as well as nature-based solutions. We cover a wide array of focus areas in the space, but our approach is focused. We are interested in supporting game-changing and disruptive solutions at TRL level 6 and beyond, and projects that are at the proof of value stage. Typically, projects that we consider must have a couple of key and critical elements of being desirable, feasible, and viable. Some of the key questions that contribute to our evaluations when we receive applications include: how needful and impactful is the solution for Singapore and for improving the livability of our cities? How innovative is the solution, and how does it compare against competing technologies? And how viable is the solution? For example, has the applicant already received any commitment from industry players to adopt or scale the solutions? We seek solutions through various platforms and activities. We have an open grant call twice yearly. Our grant call is actually open and will close at the end of March. I'll provide a link at the end of my presentation for you to access more information about our grant call. We also have a couple of thematic challenges. We reach out globally for innovations as well. Some of you may be familiar with the Livability Challenge. That is a challenge that is also now open for applications in 3 areas: food and agri, nature-based solutions, and decarbonization. We also actively engage through our work with youths and corporates and international partners as well. We have 3 main roles at the Livability team. First, as a grant maker, we provide grants to innovators to do translational research to bring their idea forward in developing products and services that will benefit the community. And we typically support operational prototypes and pilots that need to demonstrate value in a specific environment. Secondly, as a facilitator, we are active in making as a facilitator, we help innovators secure test bits and facilitate with a lot of solutions, so we can help with, when you're a connector, we are active in making linkages with VCs and investors, and even our own Temasek portfolio companies as well. Since 2017, we have supported more than 50 projects. And many of these projects have collectively gone on to raise further funding of over $400 million from external investors. Since this event is more focused on circular economy, I will be highlighting 2 project examples of innovations that we have funded so far. The first is with a company called RWDC Industries, and it is a project that we supported on biodegradable plastics. We know that plastic waste continues to be a major issue globally, especially single-use plastics. RWDC Industries came up with a solution to substitute single-use plastics that is certified fully biodegradable and manufactured cost competitively to existing plastics. They are able to manufacture products from a biopolymer called polyhydroxyalkanoate, PHA, and the compound is actually produced from the fermentation of vegetable oils, including spent cooking oils. The project that we supported was for a prototype for biodegradable straws, but since then, the company has gone on to extend their applications to products like wet wipes and coated paper. And they have since raised more than $250 million in funding from other investors. So it has gone on to be a very impactful solution and company as well. The other more recent project that we supported was with a company called New Battery, a local company, and to produce clean and sustainable lithium. Lithium batteries are heavily used in many industries and also in electric vehicles. And in a couple of years, we know that the demand for lithium will actually outweigh the mining supply. Lithium batteries, they generate heavy pollution and waste through their entire life cycle, all the way from mining of the raw materials to their disposal. The particular solution that New created was a scalable electrochemical separation recycling technology. It uses a very small amount of electricity and reagents to extract lithium from crushed used batteries. And the process will allow for them to produce battery-grade raw material to make lithium batteries. And this therefore creates a circular value chain. This process is also low cost and has near zero waste. So with this, New actually aims to make Singapore a potential producer of clean and sustainable lithium without having to own a single lithium mine. So these are just examples of some of the projects that we have supported. This brings me to the end of my presentation, but please feel free to visit our Temasek Foundation website. There's more information on other projects that we have supported. And you can also access this link or QR code or write to us to inquire more about our grants. Thank you.
Thank you, Shruti, for that presentation. I think the work done and the projects you supported are highly impactful and really will serve us well for the future sustainability of the planet and for Singapore as well. Okay, moving on to our next speaker, who is from A-Star Simtech. Briefly introduce A-Star Simtech. A-Star Singapore Institute of Manufacturing Technology, Simtech for short, develops high-value manufacturing, technology and human capital to enhance the competitiveness of Singapore's manufacturing industry. Okay, and we are very fortunate to have Ms. Joyce Ling, who is a business manager for Sustainability Emerging Application Center, to promote Simtech's capabilities and also to identify industry partners and secure industry collaborations. Yeah. So Joyce will do a brief presentation to introduce more in depth on Simtech. Over to you, Joyce.
Hey, thank you, Andy. Happy Friday, everyone. You hear us? Are you hear me clearly? Okay, thank you. Okay, my name is Joyce and I am the Business Development for Sustainability Emerging Application Center. So to promote our capability, Simtech capability, and identify industrial partner and secure industrial collaboration. So, so this is our A-Star Gantt chart, operation chart. A-Star as the Agency of Science, Technology and Research is a step block under the Ministry of Trade and Industry of Singapore. The agency support R&D that is aligned to area of competitive advantage and national needs of Singapore. So A-Star has two council of 10 RIs under Science and Engineering Research Council, which is CERT, and 12 RIs under Biomedical Research Council, BMRC, where the scientists and the researcher contribute their invention and innovation. With A-Star Technology, our enterprise division actually create opportunity for greater synergy between A-Star and partners in various type of collaboration, such as research collaboration, licensing, and spin-off efforts. So as we are one of the A-Star RI, Singapore Institute of Manufacturing Technology, Simtech mission is to develop high-value manufacturing technology and human capital to enhance competitiveness of Singapore industrial to strategize the collaboration with industrial partners. In our R&D effort over the years, Simtech has generated in-depth practical knowledge and capability, and this allows us to help local companies to solve industrial problem and upgrade the work skill, aim to productivity improvement and business transformation. So what we do is Simtech collaborated with industrial through different modes of engagement, and Simtech assists industrial to overcome challenges with technology and know-how. Today, in fact, Simtech has worked with 3,700 companies over the 11,000 industrial R&D projects and received more than 245 million of industrial funding. Simtech work closely with industrial partners to embed our technology products and services solution in different modes, in different domains by industrial partners. With this partnership, Simtech multiplies the technology adoption by more end user in different industrial sector and more than about 770 technology license that has been issued to the strong partnership. In terms of manpower, we actually grow a pipeline of R&D talents that Simtech equip fresh graduate in R&D skill and collaborate with university to train research students. Today, we have around 600 graduate students has been trained. So regarding to the knowledge transfer, we have keeping industrial upgrade in their knowledge and skill, and Simtech train the industrial in advanced manufacturing technology over the years, and more than 4,000 professional manager and executive has been trained. So this is our Simtech operation chart, where I am in the Sustainability and Emerging Application Center, which I promote the team like Xue Chen, Chris, technology under the Sustainability and Circular Process Technology. Under the Sustainability and Life Cycle Engineering Division, the team focused their R&D effort in two key areas. One is the sustainability design of operation, which look on how resources, consumption and waste can be minimized to improve resources efficiency in business operation. And secondly, sustainability informatic of strategy, which look at quantifying sustainability performance and how business models and practice can be transferred to decarbonizing operation and recirculate resources within the economy. In our capability in the life cycle assessment platform, you can see that we can actually validate the eco-friendliness of process, product and services under the entire life cycle. And the team also identified hotspot and set science-based targets, also to support eco design, systematically planning and maximize the financial ROI of sustainability initiative. On the resource efficiency monitoring and analyze suite, the team is able to manage energy, water, and waste, and even reduce the carbon-related carbon footprint. Is to assist a company to apply data-driven methodology for visualization and prediction and control of resources usage. So in the coming presentation, my colleague Xue Chen and the team will be illustrate how we can tackle plastic waste and recycling, upcycling in the circular economy. And if you are a SME or a pro in sustainability project, I have embedded my QR code, and do contact me to discuss in detail. Yeah, thank you.
Thank you, Joyce, for that presentation. Yeah, and as we move on to our next speaker, circular economy is something developing and growing, but our expert and researcher, Dr. Xue Chen, has been working on it for many years, and he's a senior scientist and section manager of the Smart Separation and Segregation under the Sustainable and Circular Production Technology team. Yeah, he has over 9 years of experience in A-Star Simtech. He initiates and manages competitive grants, research grants, industry projects to focus on industry sustainability, closed loop, continuous manufacturing, smart collection sorting, and as well as various projects funded by the Singapore government, local and overseas universities. And later on, together with him, we have Christopher Lee, who is the Senior Research Engineer in Sustainable and Circular Production Technology as well. He has more than 10 years of experience in both research and industry sectors, and leads various projects. So welcome Xue to share with us and to enter your questions into the chat box and we can answer them later. Thank you, and over to you, Xue.
Thank you, Andy, for the nice introduction. Hello, everyone. My name is Xue from Simtech Sustainability Lifecycle Engineering Division. Today, I introduce some brief concept about circular economy and see how their business opportunities can happen. And then we look at plastics, plastic waste streams, and how it can generate useful resources back to a plastic value chain. And in this program, plastic waste recycling, upcycling in circular economy, myself and our colleague from IES, which is another institute in A-Star, we are driving this whole program, and we get a lot of support from industry, from IES, from other stakeholders, and also NEA to move forward and enable industry transform their capability and fit their particular competitive position in the plastic circularity ecosystem in the future. And without further ado, let me share with you some interesting photos I collected from different sources. The urgency of plastic waste treatment, plastic waste circularity, and recycling. This is a photo of a river, and very typical cases in many developing countries. And the river is still flowing, but without a good waste management, especially the waste management for FMCG, end-of-life products, plastic packagings, bottles, a lot of containers. You can see the waste is very everywhere. Even in the developed country, people have a good attitude, well-educated, and a good infrastructure, as well as a well-scheduled waste collection. And the situation is still, because of many other external factors, overpackaging, different types of plastics, mixing in the waste streams, and due to the logistic and online business, the total amount, the type of different variety of plastic materials, multi-layer design, composite, labels, papers, adhesives, printed inks. These all complicates the recycling and the potential recycling capability for the plastic material. And even though people think about targeted collection, but consumers are still get confused. Which is the right bin to dispose the plastic? Should I dismantle it? Should I clean it? Should I take off the label? And then should I put the cap, put the bottle, and put the tray into the different bins? There's a huge gap between the consumer and the waste collection. The core reason is too many types of end-of-life products. Different products are designed at a different level of components. Components are manufactured using different materials. Some are degradable, some are recyclable, some are not recyclable, some are multi-material. And at the material level, they are dyed, colored, and also blended with additives, ingredients, and filaments. So to find an ideal mono-material stream from the waste collection, mixed rubbish collection, it is very challenging. Once people dispose, collected by the rubbish truck, all the value material and the non-value residue are mixed, intermingled, cross-contaminated. This challenges the recycling. This adds the cost to recover the valuables from the contaminants. And now you can see, even in Japan, for example, they have a good collection, good treatment, and a good infrastructure. However, the plastic is not economically viable to sort, to recover, and the majority of them are dumped into the ocean. And this is art, kind of artwork created by a Japanese artist, and he also emphasized the urgency of having a responsible, smart, and a technology to support and to start the plastic circularity from a good collection. Now we talk about circular economy. We take plastic as an example because number one, plastic is a good polymeric material designed for reuse, not supposed designed to as a one-time use material. So to recycle plastic is really aligned with the original intention people invent the plastic material. Secondly, plastic is widely used in FMCG products and a very cost-effective material and dominant the market close to the consumer. Many of the consumer brands also realized the urgency to have a circular design, recyclable design, to use more recycled, renewed plastic resins into their product, into their formulation, up to 70% projected in 2030. And thirdly, plastic material has the highest content of carbon. So technology, infrastructure, industry ecosystem, if we use plastic as the core theme, stakeholders, participants, and the companies would generate the maximum impact to reduce the carbon emission. And for Singapore, our nation sets a target 30% plastic recycling by 2030. And we support EDB ESG as well as NEA to align the local ecosystem and upgrade the technology to connect the linear supply chain, which is, if you can see my mouse, to connect the linear supply chain at the retail consumption and the waste collection stage back to the plastic value chain. For example, renewed resin or directly mechanically recycled back to a new plastic product. And we also work with the A-Star Urban and Green Technology Horizontal Office to coordinate how recycling, how collection, and how redesign can also co-work and collaborate with the new formula, circular formula, biodegradable formula, and the green plastic recipes. So this is the whole research ecosystem. And now we are going to provide technologies to enable the industry ecosystem to welcome the circular economy. There are many pathways to transit industry ecosystem to a circular ecosystem by regulation, by the influence from the off-taker brand owners, by the legislation, and by technology. Because without technology, without hardware, without the real solution on ground, policy, informatics, and other things, they can manage the current situation very well, but not able to have an innovative solution for the future. So I go to this level. And for the plastic, we need technology. We already realized the complexity in the plastic mix. And also, together with the complexity in plastic mix, in plastic product design, there's a huge amount of contamination. So in this chart, if you look at the two axes, complexity and the contamination, more or less, you can see that plastic recycling, actually, there are 4 different scenarios. Simple, clean plastics, there are already reverse vending machine in the market to collect the PET bottles. This is a good example. And this is what industry can directly jump into this new ecosystem. And however, this fraction of the plastic waste stream is really, really small. The majority, a huge amount, significant amount of plastic waste, usually they are complicated, manufactured, or heavily contaminated due to the food residue, due to the beverage residue, and due to the ink, label, and other components in the product design. So if we look at the other 3 quadrants, how do we do that? If they are disposed all together, can we think about a good collection to pre-segregate them into specific focused supply chain, and then they can be handled, they can be addressed from a technology approach. So Let's take one or two examples. We look at the up right or up left quadrant. Combined, this is less contaminated. This is less complicated, but a lot of contamination due to the multi-layer, due to other printed label. So we consider chemical approach to handle that. And for other cases, if it's heavily contaminated, heavily complexity, we consider a smart collection to find out the useful and the recoverable value material from the total mix and do the recycling follow-up. This is a slide to give people a vision how this industry ecosystem can work together and eventually can loop back to a high value add manufacturing system or manufacturing industry. First of all, this is the bar chart from NEA. Plastic is listed as the most significant waste stream, which has a quite high number of total volume. And however, if the plastic is in the red color, let me point this is the plastic waste. So the volume is quite significant. And in addition, the red color indicates the majority of this plastic volume is not recycled, it's incinerated. In Singapore, the recycling rate is only 4%. So this is the top one waste stream that NEA would like us to focus and address for this nation. And after collection from domestic, collection from the post-industry, smart collection and other waste stream sorting and segregation with separate plastics into different material streams using mechanical, using thermal filtration and advanced optics to understand each of the material categories and process them through both chemical recycling pathways and the mechanically upcycling pathways. And eventually, we also introduce LCA to understand the full carbon footprint along the entire recycling journey. And then we provide a recommendation, what's the most economically attractive pathway and also generate enough impact to the carbon reduction, and consider a good solution for the industry. So they can consider this waste stream and convert it into a renewable resin, advanced carbon material, as well as a direct redesigned packaging for the different end market. For our program, we look at to provide an open innovation platform to work with industry together and transform Singapore industry to capture not only the market in the nation, but also Southeast Asia market as well. Everybody would have a good competitive advantage for the future circular economy. And because of the bandwidth of the entire supply chain is quite broad and ready solutions from the leading countries, we also provide the connection and welcome them to set a prototypical demonstrative line in Singapore, so local SME can find a unique position, bridge the gap, develop the technology. Eventually, the end-to-end solution can be a good paradigm, and everybody can go together and address more plastic challenging issues in the neighboring country, and together with the influence by the consumer brand owners as well. We look at opportunities, and based on our bottleneck analysis, the plastic waste flow chart on the right side clearly indicated that there are 4 bottlenecks. I highlighted them on the left slide. First of all, due to the lack of efficient collection, many plastics are intermingled or blended, mixed with the other food residue, one-time use paper packaging, as well as other metal cans, glass, and the many different types of contaminations. Because of this level of contamination complexity, there is only 1% of the plastic waste stream has been segregated from PWCS and GWCS to the MRF. And the MRF, when they look at this tiny stream of the plastics and the recyclable material portion is also very low. In total, they recovered 50% out of this 1%. So only 5% or only 0.5% is recovered from the MRF. And in the nation, as I mentioned, we have about 4% plastic recovered. So where does the rest come from? They come from direct collection from the industry. They are the cutting edges and packaging waste. So they do not go through the waste collection. They are directly looped from the industry, the company, to overseas export. The majority, 94%, is incinerated. So this is the current situation. We projected the smart waste collection to increase the recyclable plastics and help the Singapore centralized waste facility, MRF, and the future pyrolysis plant to have consistent, sizable, and high-grade plastic waste streams to support pyrolysis back to petrochemical industry, and also to support directly plastic manufacturing in the local company. And this would shift the export back to the local manufacturing. This is a prototypical local closed loop ecosystem. And in long run, aligned with the NEA timeline, when the commercial scale pyrolysis has been established, more of the plastic waste streams will be piped to the pyrolysis line, and that would also increase the demand for high quality plastic collection from a smart collection. And also, this would also enable local company to secure more renewable plastic resins from waste collection as well. And without further ado, I hand over the smart waste collection technology slides to my colleague, Chris. And Chris, over to you.
Thank you, Xuecheng. Hi, I'm Chris. I'm from Simtech, working under Xuecheng, and I'm actually leading the hardware and system development team for the smart collection team itself. In terms of product and technology development, we focus on hardware, system integration, software development, UI design, data collection for information granularity design, material characterization, and data analysis. Next slide, please. To further enhance what Xuecheng actually just went through in terms of plastic waste recyclables, let me just do a recap in terms of the situation in Singapore. This data is actually from 2019. In 2019, about 1 million tons of plastic waste is actually being generated within Singapore itself, out of which 45% comes from the domestic sector. To further break down this figure, only 3% is actually being collected by recycling bins, while most of that plastic waste that could be actually be recycled, it comes from the general waste bins. What happens is that most of this plastic is being rejected or exported overseas, but majority of them is actually being sent to incinerator and landfill. Putting things into perspective, only about 13,000 tons collected from recycling bins is actually being useful towards recycling in the industry itself, and that translates to less than 2% of the overall figure. And if you think about it, the amount of waste or plastic that's actually being leaked to the environment is actually more than being collected here in Singapore that can be useful. So here, what we are doing in Simtech is actually to streamline, do a smart collection to actually recover more of that collectible recyclables. Next slide, please. Looking at the figure here, we can actually streamline down to the end-of-life plastic waste streams. This data is being generated in 2020 by NEA, the National Environmental Agency of Singapore. As you can see, the 4% recycled material is mainly being collected by the industrial sector itself or the non-domestic sector. Most of which, of the 4%, is being sent for overseas recycling, overseas manufacturing, all being recovered and generated back to the local manufacturing sectors itself. This figure does not actually show, and because there's actually no figure being collected by the NEA to show how much of that waste or recyclable plastics comes from the domestic sector. Our Proust work package 4 looks into this direction, but again, there is a lack of clarity in terms of this domestic recycling actual figures. Next slide, please. We conducted a Google survey actually to local residents here in Singapore on how do they determine what to throw into the blue recycling bin. The blue recycling bin essentially is one of the main sources that's placed around Singapore. There's thousands of the bins around Singapore itself to actually encourage residents to recycle and for their recyclables to be collected by the local waste collectors itself. Out of 10, roughly about 8 people actually said that they recycle and place their recyclables into the blue bin based on the infographics that's shown in the picture, which is actually on the bins itself. And roughly about 1 out of 10 actually said that, you know, the blue bins is actually already filled with trash. So since it's already filled with trash, and that's why they just dumped it in. But in reality, what we see here on the ground is that once the blue bin is being contaminated, people will just follow, and this result in the contamination of recyclables. This can be attributed in 2 main issues. First being the bad habits that people have been doing over the years, and 2 is a poor recycling knowledge that we need to impart to the public. Next slide, please. Technology collaboration in terms of what we are doing here in SimTech. In SimTech, we focus on the research and development of our technology in terms of smart collection, smart prototyping, for the commercialization of our technology for the industry. In addition, we are also working hand in hand with the Ministry of Education or the MOE under the Eco Stewardship Program to develop similar prototypes that can be used and actually is being used right now in schools, primary schools, to actually, 1, collect data from the waste of recyclables being generated and collected from the school's closed loop system itself. And 2, this is actually being collected and at the same time to teach young kids on how to do recycling. Because recycling knowledge has to start from young. We are looking for collaborators in all 3 phases. In the research development phase, we are looking for collaborators that has the cutting edge technology in terms of machine vision, artificial intelligence, and mechanical sorting technology. This will then enable us to work with collaborators in terms of the fabrication of the technology itself, and at the same time to push our product and make it feasible that can be used by companies. We are also looking for industrial design companies to actually enhance our product. Of course, we are also looking for system integrator companies to actually come and to collaborate together with us. Towards the commercialization phase, as we push our bins out to Singapore on the ground itself, we are also looking for collaborators in terms of waste management, where they do not just do the collection of waste, but also helps us to resolve any issues with the bins, or when our customized bins has reached the full capacity of recyclables collection. We are looking for companies that will actually help us to provide a full comprehensive package to do this waste collection itself. We're also looking for mass production companies that can actually push our product towards a general market, and also looking for data analytics company that can actually get all this data itself that ultimately will be sent to the ministry, to National Environmental Agency, the NEA, so that they can have this figure for the domestic sector. Next slide, please. And this is my last slide. So our integrated solution is not just looking at different part of the collaboration right there, but we're also looking for the characterization and classification of machines itself. Our integrated solution for the smart collection starts from the characterization phase, where we utilize machine vision and light sources, combining AI to do the classification of waste. This is being sent to the route selection for further fine optical sorting before it's being sent for the washing to remove the contaminants itself. Once there, it's being sent to waste treatment facilities where is actually being used for mechanical upcycling and chemical recycling and upcycling. Next slide, please. Look at the domestic waste collection sources here in Singapore. There's actually being mainly zoned by 3 different companies here. Right now, we are actually actively engaging with local agencies and town councils to actually implement our products and our solutions onto the ground as a test bedding facility, so that we can have this data to improve our technology, especially in terms of the artificial intelligence portion. Next slide. And this is my last slide. How do we visualize our technology is going to be used within Singapore, in Singapore local context here? In terms of the smart waste collection blue bins, we are also going to implement smart bin mobile and additional features and additional technology that can be actually implemented in housing estates. And all of this data is going to be communicating in terms in the Internet of Things and networking itself. This data would then be sent and collected at the PWCS bin center, where it's being further done for mechanical sorting. Advanced optics will be actually be implemented to further segregate the recyclables into different waste streams, and then it will be sent and calculated based on the different types of recyclables itself. And at the same time, it will actually determine the level of contamination within the recyclables and further sorted for fine recycling. Over back to you, Xuesheng.
Thank you, Chris. My last slide to give everybody an overarching structure. What's the future circular economy ecosystem to address the plastic waste? Plastic waste in terms of 3 typical cases, like what I shared in the 3 quadrant chart. Everybody can see the importance or significance of the smart collection. When a company can control this smart collection, actually it controls the origin to start the circular economy and close the plastic waste loop. Plastic waste is no longer a rubbish source, but a valuable sources for the renewable economy, renewable resin into the economy. After the smart collection, what will happen? If you look at this chart, all smart collection is in line with the major sorting companies in Singapore. They are the PWCS companies, they are MRF companies, they are companies they looking for high quality waste streams, help them to switch their output from incineration, to switch the output from export to a diversified new material streams for manufacturing, for recycle, and for chemical pyrolysis. After sorting, after cascading, which we also support them to upgrade their production line, we align their output to mechanical recyclers and the chemical recyclers, including the pyrolysis and including the new chemical catalytic pyrolysis, solvolysis, as well as the glycolysis for the multi-layer as well. And eventually, the value chain would be diversified into many different cases based on the value add to upcycling examples, recycling examples, as well as the commercial available pyrolysis and the new bitumen alternatives. Endpoint will be assessed by the LC and LCC. And at the beginning point, we deploy Smart Bin into the town council, HDB communities. Test bedding will start in this year. And we are looking forward, industry collaborators, if you have the same vision and you would like to be part of the ecosystem, own the product, and own the product to address a particular waste streams, for example, household. For example, if the Smart Bin can be further deployed in the next generation as a household appliance, if you are interested to have a particular product deployed at the school and other educational sectors, if you are looking forward at new product for office, workplaces, retail chains, shopping malls, as well as hotel sectors, the next phase of customization, let's work with together each other. We have the overall architecture, we have the AI algorithm, and we also align with all the stakeholders in the subsequent supply chain to help you find the ideal sources of the waste generation and tie and link you to the waste collector and have the good understanding how much is the cost of recovery, how can we close the loop and assess the cost and customize the solution to fit a unique use case requirement. So please contact us. This is our the QR code of myself and the QR code for Chris. Any technical question, product, design plan, and how you envision the next generation, and how you would like to have a customized, unique feature, let us know. Thank you.
Thank you, Xue and Christopher, for that very insightful presentation. And certainly that gives us a big overview of the end-to-end from the collection, the sorting, the processes involved in recycling, and also bringing it back into high-value materials. Yeah. So I'd like to invite all the presenters to form our panel to address any questions from the audience that you might have. As you can see, this circular economy is a very big need and a requirement for sustainability, and involves really a lot of stakeholders, a lot of partners to be working together. As you know, a lot of the problems that we see in industry is always because parties are working in silo, and we need to have this end-to-end plan to be able to address this effectively. And we are very fortunate to have researchers like Xue and Christopher and Joyce working very hard to make all these technologies available. So yeah, maybe I just get I get unshare, and then you can speak to us. Yeah. So anybody has any questions? Yeah. Xue, maybe you can unshare the screen. Yeah, then we can talk to everybody. Yeah. Okay. Anybody in the audience has any questions, or for any of us, can be about each of our organizations or the information shared. Yeah. Okay. So just to add on what Xue has shared about the circular economy, specifically in the plastics, I think the same thing applies to different sectors as well. Different type of materials, paper, whole long list of materials, food. You know, the same conceptual process is necessary towards the whole circular economy enablers. Yeah. So, but we see, I think what I learned from this presentation as well, plastic is definitely a very big one, staring at us, and definitely a big problem that engineers, businesses, companies in the industry can do something about to improve the sustainability goals that the organization wants to meet. So source of the materials, if you are a big producer of plastic waste, definitely you are a key player to come in. Yeah. Okay. Any questions? Yeah. If not, maybe I'll just start off some questions for our speakers. Yeah. Okay. Maybe I ask Xuechen, what has been your interaction with industry? What have the industry feedback given to you, and what do you see as obstacles to further enable the circular economy? Yeah.
We have a plan to deploy next batch of smart bins with quite significant numbers to town councils, to two different town councils, understand their waste profile, and improve the quality of the collection through our test bedding and demonstrators. And we also work with one of the PWCS company to assess this new batch using their sorting line, how much recyclables can be further increased, and what's the quality and the contamination level, and are they at the moving towards the ideal grade with less contaminants. These samples, together with our chemical recycling process, we will continue the recycling process to generate the next phase resin, chemicals, and refine the plastic pallets. Work with a few key brand owners, the resin supply as well, packaging supply, and the ultimate consumer brand as well. They have already shared with us the specific quality requirements, the recyclable new designs, as well as how they look the new ecosystem and the supply chain can stitch to their sustainable product to the next market opportunities. The whole ecosystem has been not only just visioned, but also planned already. And we are just looking for ambitious company to be the product owner. So we can transfer our technology, and you can continue have your next generation of particular customization, add in more unique features into it, and have a certain first movement advantage in this new domain. Yes.
Okay, I understand. So it sounds like you already spoken to some estate people, and they're ready to kind of adopt some of these things on a pilot basis, right?
Yes.
Okay, can. All right, maybe I'll ask Christopher, working on this project, what are some of the interesting challenges you have come across so far? Yeah.
Well, interesting challenges would be to actually get the different types of waste, or rather not just plastic waste itself. Because if you think about it, in every region is actually very specific to a set of products. For example, what we find here in Singapore, F&M brands, soy milk, all these brands is not going to be found in Japan. And so one of the challenges that was actually being placed to me was, seems like the technology you are developing is only meant for Singapore. Yes and no. Right now, we are focusing on Singapore because that is our vision as A-Star. We are to actually enable the vision for the nation to go towards a 2030 role, towards a 0% waste, zero waste, essentially. So right now, we are focusing in Singapore context, but ultimately, technology that we develop has to be transit to the business sense such that it can actually be adopted by other regions, local regions, or even in the European or Asian American sector itself. So the challenges essentially is to come up with the different types of libraries, and sometimes this is quite tedious. On top of that, we have to also consider the different amount of contaminants. At what threshold is that considered contaminated to the point that it cannot be washed and recycled? It is pointless to do that. So then this is where in A-Star we have to set and find all this thresholds itself. Yeah, it's more towards a research phase where we have to consider a lot of parameters to enable our technology to work.
Okay, right. I think Ahmad has a question. What are the most potential competitors in this project? Maybe Xie Chen like to take that question. I mean, I think what Ahmad is asking is, what are the alternatives to what is being proposed, I think, and maybe you can address what you have learned from the research. Yeah, to that.
Up to 5 years ago, people use the word smart to promote IoT rubbish bins, solar-powered rubbish bins. The definition of smart, different competitors have their own vision. And the key advantage comes from how well the solutions stitch to the entire supply chain. They become a part of the end-to-end solution rather than another piece of a standalone kind of fragments in the market. If we look at other commercially available smart bins, for example, the Big Belly, for example, other net bin, we trace the waste stream. They only go to incineration. So it's not collection for recycle. It's collection with a lower logistic cost, collection for a optimized routing engine, and reduce the manpower reliance, but without the further segregation, without the control, the consistency, and the contamination. The particular collection is still as dirty and still as contaminated as usual. So to us, it's not competitors. To us, they are also potential customer. We can upgrade that technology. So their solution would make sense in the future ecosystem, in the future circular economy. And overall, our PRUSE program, we align with many different industry stakeholders. The purpose is to stitch everybody together and connect into a circle. This is how the future circular economy should look like and have to transform towards. Thank you.
Right. Okay. I think, yeah, we need to link different parties up and build that. I think we should start from the customers always, those with need. I think more discussions is necessary to build up the places where we need to collaborate in this circular economy. Biju, you have a question you want to ask?
Yes, I have a question. It's to the TEMSUC Foundation. Just want to understand in layman's term, what is the role of TEMSUC in this plastic waste recycling and upcycling in circular economy? What is the value add you're going to provide?
Hi, Biju, thanks for the question. So we are a grant maker. We fund innovations and solutions for products, perhaps innovative products in the circular economy space that address very important issues such as food waste or plastic waste, for example. And this is and what we do is we usually support operational prototypes or pilots. So to actually bring the product or the IP or the research outside from the lab to the commercial space so that they can actually prove its value in a specific setting, so that eventually this product or innovative product can reach the market. So that's our area where we fund solutions. So we're always on the lookout for any kind of innovative solutions, either locally or globally as well, which could address some of these issues that we are facing.
Okay, I understood this way. Is it that whatever the TEMSEC involved, it's only for the Singapore, or it will be for overseas initiatives leading to this upcycling, recycling initiatives in other parts of the country too?
Sure. For Temasek Foundation, there must be a benefit to Singapore. Of course, it may be two-pronged as well. So there could be a benefit to Singapore as well as globally, which is welcome. But the project needs to be conducted in Singapore. The pilot needs to be conducted here, even if the company is from overseas.
Thank you. Noted. Thank you. Thanks for the clarification, Sudhi.
Thank you, Biju. Okay. Anybody else has any questions? Maybe I'll just do a short sharing to show you some of the documents we have here. Hold on. Yeah. So we'll share with this document of you the smart bin and some background, and we are looking for partners that have some of these capabilities that Christopher has already mentioned, but we document it down: electronics design, mechanical design, software, manufacturing, AI, IoT. Yeah. So those companies or individuals keen, you can click on the link in this form and enter your contact. Yeah. I think everybody has a role to play, and we may have even multiple people participating. And IES INCA will help to find, match, and also position each individual strength or company strength into the ability to collaborate for this. Yeah, pushing the smart bin forward. Yeah. Okay. And another activity that just to make everybody aware of is this Clean Environment Summit happening in April, where the theme is towards sustainable and climate resilient cities. Yeah, so it'll be a good event where you can see a lot of the activities in the waste management, in the sustainability is happening there. This has been the last one was 4 years ago, and it's coming back this April. Yeah, organized by NEA. IES INCA is looking at organizing a booth for startups and also SMEs, trying to get some special rates. So we're looking for interest from the community or IES members who would like to exhibit here. So we'll have a link we can send you. You can register and we can talk to you further on this. Okay, so let's get back to our questions. Okay. Okay. Yeah. Okay, yeah, Shruti has kindly shared some of the links that you can read up about Temasek Foundation and also the current grant calls and activities there. Okay.
Andy,
Yes, we have a question there, right? Yeah.
there's a question about, I can answer this question. The cost, smart technology would be very costly. Actually, we can see many of the competitors, they are moving to this wrong direction. Smart technology is not expensive technology. If we assemble a bin with all the high-tech gadgets, it's definitely will be very expensive. So we are very clear that this is a rubbish bin. This has to be a low-cost solution to address the household and HDB community as well as other domestic cases. So we define smart not only because of it's part of the ecosystem, but also it's cost effectively designed. We know what are the functions we should deploy to the smart bin. And we also integrate these functions into a low-cost architecture to make sure it's affordable, to make sure it's also competitive to the cost of the blue bin. And this is what our technology and what the competitive advantage of our technology is, and how our technology is differentiated from the reverse vending machine, from other sensor solar belly bin, and also the AI bins, and very general concept in the market.
Just to add on to Weng Yan's question, thank you for that question. Who will be the user that will pay for it, right? Yeah, I think that's where we are in discovery mode. We are looking for the players in the ecosystem that want to take the lead. Today, we're just sharing about the circular economy to bring more awareness to everybody so that we can see how this concept of the circular economy where we reduce the use of raw materials and we take waste and effectively turn it back into new materials and reduce the landfill is a very key part of this whole concept. And I think the companies out there who are in the waste management, they will need to really analyze and see how they can come in. And certainly cost is a big consideration, but it's also the environmental cost, the cost to our future that also needs to be considered as well. We don't have all the answers today. That's why we are doing a collaboration really to get conversations going, to get the key interest parties to come in and explore together and find joint solutions together.
Andy, I want one more clarification. See, this call for collaboration will be coordinated by IES INCA or SIMTech or SEMSEC. Oh.
Yeah. At the moment, IES INCA will take the lead role to try and coordinate, because we talk to many parties, industry and also research, and also IES members who may be in this space already. So we hope the interested parties can come forward. Then we can have some meetings, some sharing, and co-create solutions together. I think we need different skill sets, different players in the ecosystem to come in. Yeah, but IES INCA at the moment will just help A-Star to coordinate this, because we are closer to the industry side.
Okay, thank you, Andy.
Thank you, Biju. Okay. Any other questions you might have? If not, if there are no more questions, we'll just hang around for a while. Those who like to, have a chat or just discuss further can continue. If not, we will share this recording as well as some of the slides that can be shared with you over email, and also our call to collaboration document. You can take a look. Feel free to send potential partners or collaborators our way, or send me a request if you need to further chat or just meet up and see how your business can contribute to this circular economy. Okay. Okay, if no more questions, we will thank our speakers, Shruti, Joyce, Xuechen, Christopher, for your time and your generous sharing about your support and your role in this circular economy. And also we hope to see more sustainable Singapore emerging from our activities. Thank you very much, everybody, for joining us. Have a great day.